data and data science session. A first short announcement: we still need somebody to staff the camera in the back, which is really cool work because you get to be the camera person. And if you have any interest in that, instructions are available. Just step up here, grab the microphone and the headset, and you will be instructed on how to do it. This would be really wonderful, and we'd appreciate somebody volunteering for that. But now we're going to hear about data science and career paths in data science by Natalie and Solveiga. Please give them a warm round of applause.
Hi, everybody, and welcome. So Solveiga and I have landed the graveyard shift today after lunch, when everybody's bellies are full of food and people are starting to feel sleepy. So we're going to do our very best to keep your attention, okay? So the data scientist career path. Data scientists often get asked, how did they attain their position, and what did their data science career journey or their career path look like? So we wanted to take this opportunity to share with you some of the valuable lessons that we've learned during our career and offer a data science survival guide. So what are the things that we wish we would have known before we started in our career? So I just want to quickly introduce who we are. So I'm Natalie Jakomis, and I'm Group Director of Data at GoCo Group, which GoCompare is one of the brands within the group.
And I'm Solveiga Vivian-Griffiths. I work as a data scientist in GoCo Group.
So I'd just like to take us back a few steps and talk about the evolution of GoCompare and where we came from and where we're at now. So GoCompare was launched in 2006 after it was recognized that customers were having a hard time trying to find the right insurance deal. GoCompare was the first comparison site that started to focus on product features as well as price. And we've gone through a series of changes. We've gone public, we've become a PLC, we've diversified into new areas, and we're also home to some very well-known and well-regarded brands. GoCompare, Energy Links, My Voucher Codes, WeFlip, and Look After My Bills. So we started in 2006. We were a startup. We literally started at the kitchen table, and we've grown to become a 300 people strong group. We've now become GoCo Group. So given that you're here today, you're attending the PyCon conference this weekend, I can only assume that you were the same as me in school. You were the yellow smiling face when it came to attending your maths subjects, your IT, your statistics, and probably more often than not, accompanied by people who dislike those subjects. The path to building a great data science career doesn't need to be complicated. And as I said, Solveiga and I want to share with you some of the valuable lessons that we've learned and what are the things that we wish we would have known during our career. And offer some, I guess, some standard data science advice for those people who are looking to start out in data science.
So I'm going to start and talk about what's in the title. And so I'm going to start on the second word of the data science. And the reason why I want to do this is because when people are asked what data science is about or what do we do, the answers usually include math, statistics, algorithms, technology. And science just gets mentioned at the very end of that list, and I think it's probably one of the most important. And I think the reason why that is because a lot of huge chunk of the pipeline into the data science career comes from academic backgrounds. So we already have the scientific education, we already think like scientists, so we kind of forget that a lot of people in the workplace don't. And I think it's really important for people who do not come from scientific backgrounds to understand what's needed in this career as it comes to science, and also to educate people you work with when it comes to scientific thinking. So scientific thinking can take years to develop, so if you come from scientific background, you'll know that. And it's quite difficult to define and summarize because of that, but I'll try to do my best. So the first thing I want to talk about is the what I call scientific inquiry, and that's, in the simplest term, it's just being excited experimental and inquisitive about what you do. And it's trying to look for new ways to solve problems, to kind of imagine new aspects, applying new methods. And usually they get really appreciated in the industrial settings, because you're just bringing new ideas and they're nice and exciting. But the drawback of that is that it sometimes comes with things not working out, which is just part of science. That's what science is. You try things and sometimes they don't work out. And you need to teach people around you that it's okay, it's just the way science is, and data science is just science. So just having that inquiry, scientific inquiry, and balancing delivery of results with the inquisitiveness, it's part of the career. Another thing that I find really important is philosophy of science. And I think that a lot of people with scientific background don't like philosophy of science much, because we like numbers and data and real things, and philosophy just isn't that. But philosophy of science just means that it's translation of the data and the numbers that we get into the way we understand the world, and this is what data science does. So having understanding the philosophy of science means that you know what causality is, what association is, what data can constitute evidence. And it's also knowing that everyone has a bias in the way they see the world, and it could be different from what you have. So there's never a right method or right solution, and there's multiple possible solutions, and doesn't mean that there's a better one than yours, because everyone just have a different viewpoint. That's called philosophy of science. And the last one is scientific integrity. And I'm actually been very happy, because I think in the past 2 years, I've seen a huge shift in the data science community from just building accurate models to building fair and moral models. And that's part of it. So scientific integrity is just doing the right thing as a scientist. And the fairness and moral models is part of that. But it's also it's not just doing what you're being asked to do, it's also questioning whether this is right and whether you should do it. And that also includes right statistical methods, right models, right data, right conclusions. And it's calling out the people who ask you not to do those things and do not approach the problems that you solve with scientific integrity. And because if we do the right things, we're going to just build better community in data science. And so the next topic, so I talked about science, now I'm going to talk about data. And I called it data over models, and I think because when people start out in data science, they're really excited about the algorithms and the models and the technology, because they are the exciting things. It's always, oh, it's the next cool model or the next exciting thing, and it's never the exciting data that you're looking forward to working with. I think mainly because most of the data science is kind of taught on data sets like Iris, Boston house prices, and they're just like nice and neat and small data sets that are just selected to answer particular questions. And even for people who come from academic backgrounds, usually the data is collected to answer specific questions. Hence, they fit the questions that there are, and there's nothing interesting about the data in itself, but the career is called data science, not model science. And so what happens in industry, I think, data just is a byproduct of existence of companies rather than being collected for specific purposes. So imagine if you have a problem that needs you to have data sets of many pictures of cats. And you would think when you go into industry, all the pictures of cats look like this. So they're really nice, defined, high contrast, pretty, definitely a picture of a cat. But in most cases, they look like this. And you just glance over and it's like, well, it's kind of fluffy, it has ears, and you could say it's a cat. The problem is that when it comes to algorithms and data science, it's just numbers. If you provide some numbers in, the algorithms are going to give you numbers back, but it doesn't mean it's the right, because the data is not right for the questions that you have. And one of the biggest skills as a data scientist is kind of recognizing data like this and knowing how to deal with it, and what can I do with my e-works? One of my questions are about cats.
Okay, so moving on from the good points that Sol has mentioned, the third point is data science should be seen as a building blocks game. Now, I believe this analogy can be best applied to most learning activities, but I think it's extremely useful for our data science journey. Now, I'm sure we've all played with Lego at some point in our lives, and some of us probably still play with Lego today. But the first thing we do is we decide what toy model we're going to build. We open up all the plastic bags and we lay all the pieces on a flat surface so we can see what we have. We then understand how each part can be used. So we look at the shape, the color, the dimension, the characteristics of each part. And then we start building kind of small chunks, okay, until we master some of the uses. And then once we've done that, and we follow the instruction manual from beginning to end, and we've built our toy model, what do we do next? Well, we actually take all the pieces apart and we start to experiment again. And this is why I think it can be applied to so many different areas in data science. Because first of all, we learn what our building blocks are. Then we learn how to use those building blocks. And if we want to create something that's more complex, we look at the missing parts that we don't have. So the next point is that computing skills are essential, not just for data science, but for tomorrow's world. And when I was doing my master's some time ago now, I realized something that was constantly being whispered in reports and blogs and forums and websites and in the news. And that was that computer code attributes to more than 80% of our lives. And back then, that was true. If you think about it, we've got code in our smartphones, you've got it in our TVs, you've got it in our cars, websites, it's in our public transportation systems, it's in our health service, it's in our manufacturing production lines. But you don't have to know all of the tools. And I'm sure if I was to ask you to give me a name of a tool or a framework, we could all come up with different pieces of tools and software. We've got Spark, we've got Python, Julia, Redshift, Hive, TensorFlow, Kubernetes. There's a seemingly unending number of data science programming languages, frameworks, and tools. And I guess when you haven't worked in data science for very long, or you're new, or you're just looking to start out, it can be quite daunting. It kind of feels like you have to know all of these tools and all of these frameworks. If I go back to when I first started out, every time I heard somebody mention in a conversation a tool that I wasn't familiar with, I'd literally kind of panic inside. I would freak out. I'd make a kind of mental point. I'd make a mental note, and I'd go home, and I'd kind of research, and I'd literally turn on my computer, and I'd find all the relevant documentation that I could. I'd literally binge learn on that tool that I hadn't heard of. It wasn't healthy, and it wasn't really needed. And also, your company that you're going to work for, they're going to have their own set of tools. And from my experience, I've walked into companies where they've been relatively clueless about some of the tools that I know. So unless you're going for a very, very specialized role, your employer's not going to expect you to know their entire tech stack. They are going to expect you to learn some of that stack on the job. But you need to know enough to pass the interview, though, yeah? So you need to learn your basic tools well. Pick a small set of tools that work for you. Get comfortable with them. And don't worry too much about branching out too much too quickly, okay? At GoCompare, our group data platform is Azure Databricks, and we use Python, Spark, Scala. So my advice is to go deep on the tools that you use regularly. And don't get yourself tied up in knots. If you're finding that you're using something regularly and you're stuck, just pick up the manual. And there's a huge data science community out there. Kind of reach out to your groups and to your local meetups, and there's always somebody willing to help. So the fifth point then is model drift, and you're probably wondering where does she go in with this one? So pushing code into production is one thing, But there are key items that mustn't be forgotten about once you've deployed your code, okay? So you've got your data flow, you've got your performance measures, you've got governance. You may need to recheck your model daily, weekly, monthly, every 2 months. It may need some sort of alert. You may need to retest your model. So there's a lot of things to consider apart from your model. There's also the financial side of things, okay? So how much is it going to cost to put your model into production? Who's going to have responsibility for making sure that that model actually runs properly? So again, there's a lot of tasks and activities that require investment, time, and thought. And then there's risk. So different models have different levels of risk. You've got bias, you've got compliance, regulation, personal information. So I guess the point I'm trying to make here is that, obviously you're given your problem statement, you're given your problem, you start doing your discovery work, you then move on to your exploratory work, and you start to identify, which variables are going to be strong predictors for your target variable. You start to build your model, okay? You start to test it, train it, you move to deployment, but there's a lot of other tasks, some of which I've just mentioned, which are equally, if not more important than just putting your model into production.
So now that we heard all about it, people who are starting out are probably going, how do I know all of this? How do I know what do I need to know? And how to obtain all of this knowledge? And it can be quite scary. I've been there myself quite a few years ago. And the answer is the more you go into the data science career, the more you feel like this. It just gets worse because it's the classic case of the more you know, the more you realize that you don't know. But the thing is, I had advice when I was still in my academic career about this knowledge effect, and one professor told me that the only difference between them and an undergraduate student is that the professor knows what he's not supposed to know. And that's half the knowledge. So just knowing what's out there, it's half the knowledge. It doesn't mean you need to be an expert in everything, because you can't be. There's very, very few people in the world who are experts in the whole of data science. The thing is, the field moves in such a fast speed, it's impossible to learn everything that comes along, but as long as you know what's coming along, that's half the knowledge. If you have the skills and the ability to pick things up quickly when they're needed, that's good enough. You don't need to know all of it now before you even start a career.
Okay, so the 7th point then, practice communication. And this is something that I think is really, really important and is often underestimated in the field of data science. So written and oral communication skills, having the ability to prepare progress reports, create and deliver presentations and interactive dashboards to communicate your findings and insights to your key stakeholders will increase your actual and your perceived value to the business. You're going to have a mixture of stakeholders. You're going to have technical people, you're going to have non-technical people. You're going to have people from product, marketing, finance, HR. It's important to explain to both the technical audience and your non-technical audience any biases or uncertainties that are inherent in your data science model or process. I'm going to say something that people may disagree with, but if I was to put my kind of business context hat on, and I am saying my business context hat here, okay? The best algorithm may not necessarily be the one, for example, with the highest AUC score. It could be the one that stakeholders understand and trust enough to agree to use it effectively. So I guess getting the skills to be a data scientist with strong and effective communication skills is something that can be developed over time. But the key point that I want to make is that communication is not something that should be dismissed as optional. So moving on then, once you've built your model, so you've built your predictive classification, your forecasting model, getting to that stage can take a lot of negotiation and convincing and persuading, primarily to kind of buy yourself some time to set things up properly, to be able to provide that valuable action-orientated insight. Data science has had a huge boom in interest, and that's not going to land cold with you guys. Obviously, you all know that. But I also feel it's created unreasonable expectations when applied in a business context. At times, I feel it's reduced the great work that data scientists have done to a string of headlines and buzzwords. It's created an environment where businesses expect outcomes right away. So your ability to communicate the value and insights that you derive from your work is key to your long-term success. So in my opinion, your soft skills will make or break you as a data scientist.
So I'll finish this presentation, and I think I might just preach to the converted here, but I think like the reason why data science has come such a huge way in the past 10 years is because of the community. So there's not a single person that knows everything, can do everything, but community as a whole does. And, you know, we are part of that community. And I've never seen such immense sharing of knowledge in any other aspect that I've ever worked with as I do in data science. And I think if you want to start out in this career, you actually never feel alone, because you come to places like this, you're surrounded by people who are very willing to help you. There's online communities, there's meetups, other conferences, and if you think like, I don't know where to start, I don't know what to do with the problem that I have, just look around you and ask people, and you'll always find somebody who's willing to help you out. And I know this firsthand because that's how I started my data science career. I came here to this very conference. I didn't even consider myself a Python programmer, even though I programmed with Python every single day. And I just found methods that could solve the problems that I had at the time that turned out to be data science methods, and hence I became a data scientist. And on the other hand, there's probably a lot of people who are not starting out in data science. They've been in the career for quite a while, and for those people, I'd like to say, please give back to the community. You all have something to share. You have knowledge, data, models, expertise that a lot of junior people would benefit quite greatly from. And once again, you're here, so you probably know this and participate in this. Another thing is mentoring. So seek out mentoring opportunities. Ask around in work. Maybe people in work who are junior want to become you, in essence, and see how you can help them out. And I think the more we do that, the stronger the community will get, and the stronger the data science field will get, and the more we're going to achieve. So that's it.
Thank you very much. That was very educational. We have time for, I think, one short question, if there's one in the audience. Oh, there's one. Let me just jump over here.
Thank you for the talk. Given that data science tools are general and a lot of data scientists are kind of like working for various different organizations, and a lot of people are starting their careers as data scientists, often not in the same area in which they're currently working in, how important do you think specific domain level knowledge is of the person applying for these kind of jobs? So like, for example, understanding of, I guess, some of the products that you offer or working in finance or vice versa.
Do you want me to answer that?
Yes, go on.
Okay. So I think a lot of data science can be very fluid because the main skills you need to have apply to any field you work with, and that's why I talked about scientific skills and data skills. So I think it doesn't matter that much on the very, very specific field, but there still is a specific field knowledge, which it's possible to pick it up. If you're interested in that area, you can seek out information about that area and pick it up and move to those fields quite easily. And once again, I think it's because we have this community that's so interested in sharing their knowledge that makes moving between different areas of data science so easy. So I would advise people to never be scared that, well, I have my skills in genetics, but I want to work on finance. How do I go there? Just seek out some financial problems, and people will be willing to share the knowledge that they have about that field, and you'll gain that knowledge and be able to move there. So.
Thank you very much. Thank you very much once more.